Hello and welcome back to Compiler Programming. Today I wanted to work a bit on the functions, and in particular I want to try to implement inline functions where you specify the inlining behavior at the definition side. This will take a bit of work, I think, as inline functions are closer to macros than they are to functions themselves, and I still haven't decided what is the better approach. Do I want to have both macros and inline functions? Do I just want to have macros and make them behave like functions in certain cases? Or what is the deal here? But just thinking it in my head will not get me any closer to the solution. So I decided to just try and implement it and see how it works. If I decide that that's not what is required, then I will just change it later. So here we have token rewrite function literal that matches parenthesized expression, then arrow, then another parenthesized expression, and then the body. And the idea would be that we should be able to prefix this with the word inline that will work as a keyword. But right now, we don't really have a good way to have optional matching. So that's, I think, the first thing I will try to do. We have this token match operator, right? And I guess it's defined over here. And we need to figure out how that would work. I guess, actually, no, we do have maybe token match. Do we use it anywhere? It's in here. I think I want to call it token maybe match, just so this more consistent with the rest of the stuff. But since we have this, this is pretty good. I don't think that it's actually correct, because if we don't match, we don't actually want to advance the peak index. So yeah, if I do this, else peak index plus plus, does that work? Maybe like this. And let's run the test and see if that works. Okay, so that is the same. And now token maybe match actually does sort of maybe match, and it is up to the color. No, I don't really like that either. So maybe what I want to do is I want to do it so if I will put it here, I'll say if ID, then do this stuff like so. So if we matched, we will increase the peak index, otherwise we will not increase it. And here we just automatically return. Okay, let's try this version. This sounds good. Let's go here, and now we can say token maybe, said maybe match, and the name of it will be line, and this is going to be type token type ID, and source is slice literal, of inline. Okay, nothing should really change. All the tests should still pass. If I did everything right, looks like I did. That's good to know. And now we can actually try to make a test for that. Okay. Should be able, I don't know where to stuff this. I probably should reorganize the test at some point. Parse, and maybe this would be a good source for this thing. So we'll say ID is inline ID function. So the idea here is that this function should be invisible in assembly output, and it's a bit tough to check for that, I guess. I can try to look for calls inside of the test function. Maybe that would work. It's a bit not really nice, but let's start with that. So test, and I will say that it returns ID of 42. So ideally what we would like to see here is just move RAX 42 inside of assembly. And I will not do any tests for now and figure out how to do it later. To do figure out good assertion here. Okay, that seems fine. This test should pass because right now we are just ignoring the inline thing, but as we work on our code, we should start see it fail, I guess. Yeah. Actually, no. Interesting. I think I know what's going on. Maybe. So U64 replacement count is inline, then 5, otherwise 4. So it's good to do a test because you never know if things actually gonna work. Okay, now everything is correct. So what was going on is like the way our setup works, whenever we come across an expression like this, if we matched some part of that expression, we are taking that and replacing it with a special token that contains, instead of sort of textual representation, it contains the internal representation of this thing. So it will be a token for the function, and if we are replacing incorrect amount of things, then for example we would end up replacing just this, and then ID would be a block of X, which doesn't make any sense, and obviously errors are not great. We have not really worked on errors too much, but yeah, it was failing. Right now it does the right thing. All the tests are passing, which is good. So maybe we don't even need assertions in that sense, that it works just fine. Actually, I could leave this here, and that should be enough for us. And we will look at assembly separately. Okay, let's open up Visual Studio so we can look at assembly and see right now that we will have a call there. And later we will replace it with something else. So here's source spec. Let's look for inline. And okay. stop here. We can look at the assembly. We have a call. Yeah, and as you can see, there is a call over here. And this is the call to ID. And if we look, this is the ID function. It is very stupid. It just, like it doesn't even need to do this. So this is something to fix as well. Like if we are not using any stack, then we shouldn't do sub and add. It's just useless. But the important thing is it copies the value and returns. Anyhow, this is what we don't want to see. Maybe it's okay if we actually see the function in the output, but we should not have this call. Instead of this call, we should just have move arrayx 42. So all of these 4 instructions should be collapsed into one move if we are successful with our inline stuff. Okay. And the reason I'm doing it through functions and not through macros, because functions already have this mechanism of matching the overloads, and I don't want to sort of duplicate it. I could turn all functions into macros, I guess, but like it's a bit more finicky. So for now, this is the approach I'm going for. Okay, what is the next thing? Well, next is we need to do something different depending on whether this is inline or not. And how would we do this? So this block of code deals with externally defined functions. That's perfectly fine. I guess the only thing is we should not allow externally defined inline functions. So if is external, if inline, then we should, what should we say? We should make an error. Something like this, I guess. Program, label name location, we can say inline location, and say that external functions cannot be inline. And we just say inline is 0. So we are just ignoring it, but we are outputting the error, so the rest of the compilation can do what it's supposed to be doing. We can even add a test for that, I guess. Why not? Should report an error for inline external function. And this is like this, I believe. So bar. Yep. And I think if I try to run this test right now, it should fail, saying that we had errors. Interesting. Yeah. We do need to provide a valid DLL stuff here. So that would be kernel 32 DLL, and that's right file. Did I mess it up somehow? Let me get this out of external kernel 32 DLL exit. Well, let's try exit process. Maybe write file is somewhere else. Okay, we have a failed test. And I guess we need to change these to something else. Where do we test errors? Okay. Let me check. Inline source space. Yeah, I guess that's what I want. And then I can check for errors. So yeah. This should be like this. And if errors program errors. Is that any better? Okay, so that's good. That's good progress. Let's continue. Okay, if external, we are just ignoring the inline and reporting that. Otherwise, what are we doing? Well, we have a builder. Okay, that's makes sense. So yeah, for now, we will still output inline functions in the assembly, but we should not be calling them. So there is this token parse block for body. And this is where we need to do something tricky. So the first thing is basically we need to store the body so that we can insert it in the right places. We kind of already do this, I think, inside of the macro replacement. So we have token rewrite macros. What does this do? Rewrite macro match. Okay. Token rewrite macro match. Okay. So it creates this pattern stuff. And then we have token upright macro replacement. So we need something like that as well, except we don't have replacements. So we are not doing this ID stuff. So let's just take that stuff and insert it into here. Okay. Although it's not gonna be even happening here. Well, no, we need to copy this stuff, I guess. So token clone tree. Do I already have clone? Ah, actually I do have. Token clone token array deep. that sounds like what I want. Then I don't need this stuff here. The only thing is that token clone array deep. I don't want array deep, I want token clone. And the way that's gonna work is like this. We need to predefine this function, and then I would have a token pointer. Actually, token star, I shouldn't do token pointer. Token clone deep. Token star token. And we're gonna take this stuff here. We're gonna put it, yes, the brace. So we take all of this stuff. Now this is gonna be a copy, and we return a copy. And this goes back here, and result. This is actually doing the wrong thing as well. It was putting token itself into the copy instead of the copy, so this was working by accident. It's good that we looked at this function. So we can say token star copy is token clone deep of token, and we would put clone here. Maybe we should call it clone for consistency. Clone, 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 and return clone. Okay, does that still build? It does still build. Let's run the tests to make sure we haven't messed up, even though it was broken in the first place. I mean, if we fix something, we still need to run the test because maybe two broken things ended up being the unbroken thing. Okay, so now we have token clone deep, and the reason I said we need token clone deep is because here, before we try to do anything with the body, we need to stash that body on the function builder. So we need to say builder inline body is token clone deep of body. So actually like this, if inline yeah. Obviously, builder does not have inline body yet, but it's something we can fix. It is inside of the value h. So we just go to function builder, and we can say that it's gonna have token star token inline body. Oh. Huh. That's a bit awkward. Okay. Needed to forward declare the token here. Now we have a stashed version of the body here. And I'm still doing the defaulting, I said, because otherwise it might be problematic. Although, is it though? Let me do fix me. Should we not do this for inline functions? Or to do Um, no, actually, we need to do this for inline functions as well. So here's the thing. On one hand, we don't want to do this for inline functions, so we don't generate extra assembly. On the other hand, if we try to assign an inline function to a variable, so we have like a function pointer inside of the variable, we do need for it to be a valid function that we can call later on. And then we either will need to do this lazily, so like the first time we try to assign it to variable instead of calling it, then we do this, or we just always do that as we do right now. For now, I'll just, let's add the to do. Might want to do this lazily for inline functions, something like this. For now, that's not really a problem. Now we need to have a call. So we have magical arguments, rewrite function calls. This is the thing that is important. Okay. So we will have problems with explicit returns. So if we had something like return x here, then wait, not here. Here. Like if you would say return 42 and then x here, or I don't know, if x more than 0, then return 42. So if we had something like that, we would have issues because we need to change this return 42 into something different. It needs to sort of, well, kinda. It depends. Maybe we don't actually need to do this. Let's see. For now, I'm just worried about the easy version. Because with easy version, the only thing that we need to do to make inline functions work is take this block, we stick it over here, and so let me sort of write out what's supposed to happen step by step. Right now, we stashed this body as tokens inside of the function builder. This was an inline body field that I added. Once we call this, so if we have this stuff, it's supposed to be replaced by just this, but we also, same as with regular function call, we actually define the arguments the way they're supposed to be defined. So we would like create a new scope. I mean, this does create a new scope, right? Anyway, so this is nothing really new. We create a new scope. We define x to be whatever is the argument. In this case, it's going to be immediate 42. So, and then this will be a regular sort of execution as if we had something like x. So yeah, this is what it will sort of be like. We have a constant x defined as 42, or actually it's not really constant, it's like this, I guess. It's somewhere in between. It's a bit weird how arguments are done. And then it's x, and it's obvious that this will be just 42, and this is the inline evaluation. And again, with return values, I think they might just even work explicitly, but we'll see. For now, this is what we need to do. So there is this call function value array, And the question is, do we want to do inline expansion there, or do we want to do inline expansion here? That's a very good question. I believe this is it inside of here? No, it is inside of the function C. Okay, what do? You try to find this and call it right away. Okay, so let's split this up. I would say return match value. And then find function overload, or find matching function overload, something like that. And then in here, we would say, what will this return then? I guess it will return match. What are you doing? Descriptor function? What is the call? No, it's value. Okay, so it still returns a value. That's fine. And then here we say like this. So value star overload is function. Find the matching function overload of all of this stuff. And I guess then it doesn't really need location, maybe. Do you use location then? No, you don't. So this, it doesn't get location, which is much better. Let's say source location is this. And we say overload, builder, target arcs. And then we say if overload then we do this. This will be 0. Error handling here is going to be a bit tricky. I guess we do it like that, and otherwise we will need to say that could not find matching overload, and here we replace it with nothingness. And I can add, I guess, to do here, and better error message. We can say for function and then function name. Already that would be target token. Yeah, it might not be an ID, so yeah, let's leave it at add better error message. Getting back to here, so we've tried to find overload, and then we do call function overload with builder location overload and arcs. Yep. That does not seem good. much better. Source location with source location star. Okay, let's try to run the test. We have not really changed anything, so everything should be as it was before. Yep, everything is fine. That's good. This process of trying to keep the program working as you do stuff is pretty nice and pretty important. Okay, so we found an overload, and now we just say if overload. Oh, that's actually a very interesting thing. That means that we should not be stashing the inline body on the function builder because we don't really not necessarily have it at that point, right? Or do we? So descriptor function. We have arguments and stuff. Yep. We kinda don't have it. Operand. So I guess we need to stash this stuff on the function descriptor, which is not as nice. Descriptor function, but we don't really have any other option. So token star inline body. I'll think about what is the if there is a better way to do this, but that can be done later on. For now, we'll just keep it like this. And that means that we say descriptor function inline body. Like this. Yeah. So if we say if overload descriptor function inline body, let's make this value star inline body is this. If inline body, then we do one thing, otherwise we do another thing. Okay, what do we do when we have inline body? So this doesn't have a return value because, well, I guess. Yep. This needs to be a token. And now you say that a return value might not be initialized, which is great. This is what I wanted. Now we don't do call function overload. We will look at what call function overload does. Call function overload. Here you are. Yeah, we technically don't need to do any of that. Instead, we need to do what the previous thing was doing, which is define stuff here. Rewrite statements, arg, function scope, define value, function scope. Yeah, so basically this is what I want to be doing roughly. Let's try to figure this out. So I say scope star body scope is uh, scope make of scope, right? We are executing this inside of certain scope. We create a nested scope inside of that scope, and we need to go through the arguments. For that, maybe the better way would be to do this descriptor function is like this. Function function inline body. Okay. Dynamic array lengths of function arguments. Is that the thing? Yep. Okay, function arguments. Then we get an argument which is a value. Is the value? No, it's not a value. No, it is actually a value. That is a bit awkward. And the reason it's a bit awkward is because I actually need to know what are the names of the arguments so that I can define them correctly. So I guess array slice argument names is what we want. And here, for now, let's just do it like that. So the thing builds. And it might even sort of work. We might have a crash in tests, maybe. Yeah, we do. Okay, but that's fine. I still want to leave it in this state, maybe. Okay, so we need to get argument names into the descriptor. Descriptor is created in function begin. Yes. Descriptor. Okay. And I can say argument names. Okay, so at least we created the array. And now inside of this stuff here, we actually need to use that array. What is the arg? There is arg name somewhere, right? Not arg name, yes. So we need to also do dynamic array push this descriptor function argument names name. Okay, so now we have the names, and we can do assert that dynamic array length of this is the same as dynamic array length of descriptor function arguments, right? So we make sure that the count of that we have matching names basically for all the arguments. Tests will still fail because we're doing the bad thing there. I guess what we can do is remove this stuff altogether, and then we don't have any inline things. So it should actually work now. It does not. That is a bit suspicious. Okay, where do you explode? Dynamic array, ensure capacity. So we're trying to pass a null into here. I thought I created the argument names, but apparently I didn't. Where is this function descriptor coming from? Function builder, descriptor, okay. Okay. Oh, this is an internal, yeah, okay, gotcha. So what's happening there is we actually create the descriptor in here, and that means that we need to do this as well. Argument names, array slice, something like that. Let's see if that's any better. Okay, cool. We still have a working program. That is nice. Now we can continue what we actually wanted to do. So we have our arguments, but now we will say slice arg name is dynamic function argument names I. Since we already matched that the function is correct, and right now we don't allow named arguments, so we don't do any kind of mixing and matching between the names and arguments. It's just strictly positional. We don't need to do anything else here besides just saying, okay, we'll get the name for this argument at this position, and then we will simply do scope define value, body scope, and then we need arg name, and then we say, let's keep it separate. Arg value is dynamic array get of args I. So we define the value. That's nice. We don't need any of that. And instead of here, what we want to do is token match block, what is it? Token parse block. So basically, we are doing exactly the same thing as we did before, except now we don't have. So the difference is when we do it for the function definition, our arguments are defined to be in particular registers that according to the ABI that we have. So like first one, if it's integer, it will be in RCX, RDX, and so on and so forth. In case of an inline function, we just point them to actual values that we have in our program. And like this is stuff, right? And then we just do this. And this is a bit tricky because we have this result value, and this is very interesting. I think I have not converted the function call yet to use result value correctly. So that's a bit awkward. Return value. What should I do here? I guess I should be using result value here. And I should be using result value here as well. And then that is very interesting. So call function overload should technically accept the result value as well. Okay, another detour before we continue with inline stuff, which is fine. Call function overload. Yeah, you're no longer supposed to return anything. Descriptor returns result value. If return size is less than 8 and return size is not 0, yes. So here we no longer reserve stack. We don't do this stuff. And then here we would say value star result value. Where is the result defined? Huh? What? Oh, okay. So we either return the result directly or we this is going to be awkward. So the function calls, they have two types of returns. One is when we return inside the register. Another one is when we pass in the register containing the address of memory for the thing to be written to. And that is just not very friendly to what I have done in other places. So let's check. If we, well, this seems reasonable. So we will move the value into whatever we want from the descriptor returns as long as it's not 0. And if it is 0, then we will have void stuff. Maybe we can get away even with returning a void thing, but we'll see. Maybe void needs a separate thing. Okay. Args. Okay, now we'll likely have problems. But let's see, maybe we'll get lucky. Well, it looks like we are lucky and everything is actually working. Not everything. There is a problem. I always forget how to get error code inside of the shell. Okay, PowerShell print status. That's what I want. Status code. Get exit code. Oh, actually, this works. Yeah, so we have a non-zero status. So that means that something actually failed. What does our test do again? So I assume this thing, yeah. So all of our executables are completely screwed up. So why does all the other stuff work? That's kind of interesting. I wonder. Actually, no, it doesn't really work because FizzBuzz is also broken. I haven't noticed that. We don't have numbers here. Okay, so what do we do about that? I guess let's return this as it was. And we're gonna do this here. Return value. Okay, this is what we're gonna do. Return value is result value. Okay, and instead of the body, we will have function inline body children. And instead of the function scope, we have body scope. Value differs, yes. Okay. Don't know what's gonna happen when we try to do this now, but let's see. Assertion failed, unknown descriptor type. That's kind of awkward. Where is this coming from? I guess it is this return value that is problematic now. Who calls you? Okay. So that seems fine. And inside the block, what happens? Inside the block, we have match statement, value. Yeah, so the problem is in value any is causing an issue somewhere. Let's see exactly where that is happening. Reserve stack, rewrite definition and assignment. Okay. I'm not exactly sure where that happens though. What is location? It's FitzBus line 43. And the name is std out handle. Okay, so it is unhappy about this line. We do this thing. I think I didn't undo fully. Yeah, it should be like that. Okay, so nothing explodes, which is great. If it works, we will only be able to see it inside the assembly, so we have to run it here and break over here. Did it break? Yeah, okay. Disassembly, let's step inside. Yep, this is exactly what we wanted to see, so now it actually works. The way, so we don't have a call here now, as you can see, and we have 42, so 2A is, let's, come on, we just do. Yeah, as you can see, 2A is 42 in hex, so this is what we exactly want to see. As I mentioned, we still have the original function, which is not optimal, like we are wasting space inside of executable, but that is a separate topic for optimization. For today, that is what's important is we have inline functions now, which is very, very neat. And the reason I wanted to do inline functions is because we should be able to start moving all the assembly stuff into inline functions, which is kind of nice. Before we wrap up, I do want to try to have explicit return and see if that's actually gonna work or not. If it doesn't, I will probably do it separately, but if it does, then it's very nice. 90 functions with an explicit return. So the way that's gonna work is we're gonna say that if x is more than 0, return 0. Otherwise x. So let's see what's gonna happen. Oh, not great. Okay, let's quickly look at what's going on and why it fails. We have compare. So it actually fails at compare. And the reason it fails at compare is because we have two immediates, no? What's going on over here? Builder, result value. So this move value that fails. Operand is registered on memory. And what is the target here? Target operand. So we are trying to move into a bite-sized idiot. And that means that compares did not do something very good. Is it the result value that is immediate? Yes. Yikes. How did we end up with result type that is immediate? Result value, yes, that is correct. Am I changing the result value somewhere? Like this should actually have constant folded because both of them are immediates. Okay, this is kind of interesting. So both A and B should be immediates. You're immediate and you're immediate. Okay, I want to see what's going on. Source. Run till here and the cursor. Okay, which test is failing then? Okay, so it is very unhappy. I don't know how to get if program return. I just need a useless statement here to break on it because otherwise it's really unhappy with me. Let's build this. Okay. Now I can go back to function. Yes, and here we have compare, right? Compare, 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 compare. Here, I guess. Okay, this is what I want to see. Step into here. Operation is compare signed integers. Okay, now let's look at this. What is A? What is B? Okay, so it is not actually. Is this the right test? Yes, it is. Yeah, X is not. Wait, X. It shouldn't be RCX. Why is it RCX? Now I'm even more confused. So B is an immediate zero. That is very straightforward. Yes, it is. Why is A a register? Wait. Body scope. Yeah, it doesn't really make sense that it's a register. Rewrite function literal. Oh no. Okay, that's fine. This is this was the non-inline version of the function, in which case it is a register, everything is fine. So this is the one that I'm interested in, where it is an immediate and it is an immediate. So again, A is an integer, B is an integer, they're both immediates. It's kind of interesting why result value is, no, result value is any, that's actually correct. Okay. So what does maybe constant fold do? Define maybe constant default. Ah, okay, so that would explain it. It's missing a return. This is what it's supposed to do. Now we should be in a better shape. Okay, we have a failed test, but that's actually expected because I didn't change the thing here. We're supposed to get 0. Well, let's do 21 just so it is not a 0 value and we are sure that we got the right thing. Cool. So it looks like we actually get the right answer. That does mean that return works inside blocks right now, which is a problem by itself, but that's not a problem for today. For today, we have a fully working inline function implementation, and that's great. Yeah, that's gonna be it. If you made it this far, then thank you very much for watching, and hopefully see you next time.